Here in this video we're going to look at the two trig identities, and we're going to look at an example of how you might use them to answer a problem. So we're firstly going to consider, let's say we have an angle here. If we call this theta, that means that this here is theta. What we're effectively doing here is creating a right angled triangle. If I pull this right angled triangle out, I have an angle theta here. We know the x-coordinate of this point is the cosine or the cos of the angle. So what that means is this length here is effectively cos theta. We know that the y-coordinate of this point is the sine of the angle. So basically this length of the triangle here, that length is sine theta. And because it's a unit circle, the distance from the center of the circle to the outside of the circle is always 1. So this length here is 1. And from here, because it's a right angled triangle, we have it's basically an identity that comes from Pythagoras. This side squared plus this side squared equals this side squared. Sine theta all squared, which we write as sine squared theta, plus cos squared theta equals 1 squared. And we know that 1 squared is the same as 1. So this is our first identity here that you need to know, and does come in handy sometimes. Sine squared theta plus cos squared theta equals 1. That's our first identity. The second identity relates sine, cos and tan together. And again, if we consider an angle, let's say we put it here again, and we draw a line through it, and then to the tangent line, what we create is two similar triangles. This small one here that I've just drawn, so let's pull that small one out. Theta. As discussed before, this is going to be cos theta, and this is going to be sine theta, and this is going to be 1. And then the second triangle, which goes all the way up to here, and then down, and remembering that this y value here is the tan of the angle, so effectively this height here is tan theta, and this length here is 1, because it's the radius of the unit circle from the center to the outside. So this larger triangle, which comes out looking like this. So with this big triangle here, it's got a base of 1, it's got a height of tan theta, and because these triangles are similar in that they share the same angles, they both share this theta and they both share a right angle, and therefore the third angle must be the same, their sides will be in the same ratio. So we see that sine theta over cos theta, which is this side over this side, will be in the same ratio, the same value as tan theta over 1. And simplifying this, we come up with our second ratio, sine theta over cos theta equals tan theta. So this is our second ratio. So these two ratios can be used sometimes interchangeably. They give us the ability to answer some questions where we might be given sine of an angle and we need to find cos or tan. But there's also the approach of using right angle triangles to find these. So I'm going to work through this example and show both methods, and then you can decide which one you like better. This question here, we've got sine of b, so some angle b is 3/7, and b is between pi on 2 and pi. So that's enough to tell us that the significance of this information here is telling us that we've got an angle in the second quadrant. So this is telling us that b lives somewhere over here. So it's got a positive sine value, but it's going to have a negative cos value and also a negative tan value. So straight away we're thinking, well, cos b is going to be negative and tan b will also be negative. If we want to use the identities that we learned before, our first identity that we learned was sine squared theta plus cos squared theta equals 1. So we could use this identity to work out the value of cos b. Sine b is 3/7, so sine squared b is 3/7 squared, plus cos squared b equals 1. This is 9 on 49. If we then take that to the other side, 1 remembering is 49 on 49, and if I take away 9 on 49, I'm left with 40 on 49. Cos b is the positive or negative square root of that. And because of the quadrant that b is in, we are only going to accept the negative answer. or the negative value I should say. So cos b will be negative root 40 on 7. That's just simplifying that surd. So we have cos b is negative root 40 on 7. To find tan, we could use the identity sine over cos. So sine theta is 3/7 divided by cos theta, negative root 40 on 7. Dividing a fraction, I flip the second fraction and turn it into a multiplication problem. I can cancel out these 7s and I'm left with, sorry, that shouldn't be a square root. I'm left with negative 3 on root 40. So there's my values for cos theta and tan theta using both the Pythagoras identity and the tan equals sine over cos identity. Let's erase that now and let's look at solving this problem using a right angle triangle approach. So the second way we have of solving this is to actually visualize a right angle triangle that would have a sine value of 3 on 7. So if I just draw any old right angle triangle, I'm going to ignore the idea of the quadrants at the moment, and I'm just going to set up a right angle triangle like this. Sorry, I'm not going to use theta, I'm going to use b. So if sine of b equals 3 on 7, the sine ratio is opposite over hypotenuse, so opposite over hypotenuse. And then using some Pythagoras, I can work out that this side would be root 40 because I would have 3 squared plus this squared equals 7 squared, and I get root 40. And then by looking at this right angle triangle, I can see that cos of b will be adjacent over hypotenuse, and now I consider my quadrant, and I see that, okay, b is actually in the second quadrant, and in the second quadrant, cos values are negative, so I'm going to put a negative in front of this. And tan b is opposite over adjacent. And again, b is in the second quadrant, and in the second quadrant, tan values are negative, so I'm going to put a negative. So just by actually drawing up a right angle triangle, it's actually a lot quicker than doing it using the identity. So you've got two methods there that can work for you.